What up, Matthews? So in this section, we're going to be talking about factoring polynomials. In the last section, we learned how to multiply polynomials, and so essentially factoring polynomials is doing the undoing of multiplying polynomials. So when we learned about fractions, for instance 20 over 25, and we wanted to simplify them, we looked for what is called a greatest common factor. So 20 multiplicatively is made up of 4 and 5, right? And 25 is multiplied of 5 and 5. And so since they both share 5s, right, and that's the largest number that they share, that is the greatest common factor between them. And so when we're factoring polynomials, we're going to be looking for the same thing. We're going to be looking for the greatest common factor. All right? So if we were given two monomials, remember mono means one, meals means terms, so just one term. So if we have 18x cubed and 21x squared, and we're looking for the greatest common factor. So what is the largest term that is multiplicatively both in these guys? Well, so if we think about 18, right, and we factor this, it's 6 times 3. And what is x cubed? It's x times x times x, right? Okay, let me move this one over here. Make my and a little bigger. What is 21? Well, it's 7 times 3, right? And x squared is x times x. So essentially what you can do is circle all the terms that they have in common. Well, here's an x, there's an x, okay? Here's an x, there's another x. This one's out of x's, so we can't circle anymore. But they also both have 3's in common. So if I circle a 3 here, I circle a 3 there. And so this is the greatest common factor. It's the greatest combination of terms that they both have in common multiplicatively. So the GCF here would be the 3 times the x, which we can simply write as 3x squared. Okay? And so, well, why are we doing this? Well, if we know that this is the greatest common term, essentially what we can do is we can pull this out of both terms. So if we had 18x cubed plus 21x squared, and we know 3x squared is the greatest common factor, we can rewrite this as 3x squared, right? We took it out of both of them. And so what's left over? Well, in terms of the 18x, right, we have the 6 left over and an x, so that is 6x. And what do we have left over in the 21? Well, we just have the 7. And you'll notice that if we multiply these back in, right, 3x squared times 6x, this is 18x cubed. And then 3x squared plus 7 is 21x squared. And so you see that these two things match. And so really the idea behind it is that last section we were multiplying polynomials, right? We were starting here and going this way. But now in this section, what we're going to be doing is we're going to be starting at the terms that have already been multiplied and trying to figure out what way we can break them down. Okay? So this is the same technique. Now, what if you have a whole bunch of terms being added together, right, and not just two? Does it really change? Not much. So, for instance, let us do a more complicated one. And so we're looking for the greatest common factor of 70x squared y cubed plus 7x y squared plus 14x squared y squared. Okay? And so let me rewrite this y so it doesn't look like an x. Give it a little curve. Here we're looking for the greatest common factor. So we want to find the biggest number that is multiplicatively inside of here, but then also for the variables as well. So here we have two x's, right, in this first term. Okay. Here we only have one x, and here we have two x's. So what is the greatest amount of x's that we have in common between all of the terms, right? It's just 1, because this one doesn't have two of them. So we know that x is going to be something that we're going to be able to factor out. Okay? And so let's look at the y's. This one is 3y's multiplied together, right? Y cubed. This one has 2y's multiplied together, and this one has 2y's multiplied together. So what is the biggest number of y's that they have in common multiplicatively? It's y squared, right? 2y's multiplied together. So we know we can factor that out of all three of them. And now comes the hard part. Usually the numbers are what people struggle with the most, but it's not all that complicated. So what numbers in here do we have multiplicatively that all three of them share? And so if you are good with your times tables, this may be a little easier to see, but if you are not seeing it just by looking at it, you'll need to prime factorize these numbers. So what does 70 break down into? Well, it's 10 and 7. 7 breaks down into 7 and 1, right? That's all it does. And 14 is 7 and 2. And so you can see that there's a 7 in all of these terms. And since this one only has a 1, well, that doesn't even really matter because we can always factor out a 1. And this one has a 2, and this one has a 2 technically. If we broke 10 down, we'd have 5 and 2. But since this term doesn't have a 2, we can't factor the 2 out, right? Remember that they all have to have it in common. So the biggest number these three terms have in common is just the 7. And so what's left? What is left on the inside of these terms once we factor this common term out? Well, so we just basically need to think about this term times what gives me 70x squared y cubed. And so numerically, we know we need the 10 to go from 7 to 70, so we know we have a 10 here. We're missing an x, right? X to x squared, so we need one x here. And then we're also missing a y because we have y squared to y cubed. So we're going to need a y there as well. Okay, now for the second term, we have a 7. Okay, so that checks out. The numbers are already accounted for. The x, look, we already have all the x's as well here. And now if we look at the y squared, all this term has is a y squared, so we don't need anything, right? And how do we write nothing multiplicatively? 1, right? If we take everything away, always what will be left multiplicatively is a 1. Cool. Now let's look at the third term. So we took a 7 out. What factor is left in here? We took the 7 out, so there's still a 2, right? This 2 right here. How many x's are left? Well, we took 1 out, but this one had 2, right? This one had 2 of them, so we know we need to put an x in here. And this one has a y squared, but so does this term, and so we don't need to put any y's here. And to check our work, all we have to do is just the rainbow method and distribute to all three of these guys and see if we get the number on top again. So 7x times y squared times 10xy, 7 times 10 is 70, x times x is x squared, y squared times y is y cubed, 7x times y squared plus 1, that's just anything times 1 is itself, 7x y squared times 2x, 7 times 2 is 14, x times x is x squared, y squared times 1 is y squared. And so does this match our term here? Yep, they all do, right? So we know we factored it correctly. So our factored form, our simplest factored form from here is now this, because 7xy squared is our greatest common factor. Alright, so we'll stop the video there, and I'll see you guys in the next one.